Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, you learn about AWS services. Today, we are going to talk about part 3 of our series, AWS Glue Job Optimization. So let's get started. So, some of the prerequisites. So, AWS Glue Job Optimization is a fairly advanced topic. So if you don't know about AWS Glue, lake formation, how to use PySpark with AWS Glue Job, then you need to know that first. And in case you know these things, then you can simply move on to the and if you're not, then I going to provide certain links in the description below, and you can use those links to understand fundamentals of Glue Job and fundamentals of PySpark. I also recommend that you go through the first 6 minutes of AWS Glue Job Optimization Part 1, because that helps you understand how I have organized the topic, and you will not feel lost that what exactly I'm talking at random out here. So I do recommend you invest 6 minutes of your time going through part 1 to understand how I plan to organize my topics. So with this prerequisite in place, let's get started. So today's technique is, so we all know that if you're using AWS Glue Job, it uses Apache Spark, and it uses parallel processing, parallel computation. So today we are going to learn how we can optimize this parallel processing using grouping of the files. And such grouping not only optimizes the memory consumption, but it also enhances the performance of the Glue job. So let's try to understand how this technique works. Before we understand that technique, and to be honest, applying the technique is pretty straightforward, but before you apply, it's important for you to understand how Glue job capacity works and how that capacity turns into parallel computing. Because once you know that, then it will be easy for you to understand how to apply the technique. So in Glue job, when you're trying to configure the capacity of the Glue job, you provide number of workers, and then you provide worker type. So number of workers could be 5, 10, 50, 20. There's an upper limit also, I think 399 or something like that. And you also provide worker type. And your worker types are three types of standard, G.1x and G.2x. But here I have kept the standard out, and I'm just comparing G.1x and G.2x, which are latest generation worker available in Glue job. So if you are using a G.1x type worker, then this worker type, this one worker type gives 1 DPU, and that is equivalent to 4 vCPU and 16 GB of memory and 64 GB of disk space. You can also configure to choose G.2x as the worker type, and in that case it will be 2 DPUs, and that means it will be 8 vCPU, 32 GB of the memory, and 128 GB of disk space. So basically these are the two parameters you configure for the Glue job capacity, number of workers and worker type, and depending on this configuration, it decides how many vCPUs and how many GB of memory and how many GB of disk space will be allocated to your Glue job. So let's take an example of a capacity and try to understand how it helps in parallel execution. So let's assume that you go for number of workers equal to 10x, and you decided my worker type will be G.2x. So in that case, you get 20 DPUs, because one worker type of G.2x gives you 2 DPUs, so 10 into 2, you get 20 DPUs, and then you get 8 into 10, which is 80 vCPUs, 32 into 10, that is 320 GB of memory, and 10 into 128, which is more than 1 terabytes of disk space. Now, let's try to understand how it converts into parallel, how it helps in, not convert, but how it helps in parallel execution. Now, since you have decided 10 workers, there will be 10 workers. Okay, and then each of these workers can do parallel processing. So, well, by having 10 workers, anyway you have parallel processing where there are 10 workers who are doing job for you, but within the worker itself you can do parallel processing, and within the worker parallel processing is done by this Spark task. So these gear boxes, these gear icons you see, each of them are Spark task, and even within a worker you can have more than one Spark task. Now the question comes, how many Spark tasks I can have within one worker? Well, that to be honest, there is no public documentation which I can refer to here, but what I understand, this number of Spark tasks is roughly equivalent to how many cores you have in a worker. So if you have 4 cores, then you roughly get 4 Spark tasks. If you have 10 cores, then you get 10 Spark tasks. So in other words, you can say that your number of vCPUs in a worker, like in each of these workers have got in fact 8 vCPUs. So number of vCPUs in worker determine number of Spark tasks running in per worker. Now what these tasks are fundamental unit of your execution. These tasks actually execute your work, and to do so, what they do, suppose if you are reading from Amazon S3, each of these tasks will take a portion of your data and will simply process that data. And it will process, and in order to process the data, it will be allocated certain CPU and certain memory, and of course disk as well. So you can see that each of these Spark tasks are allocated certain CPU and memory, and then these Spark tasks actually take a portion of your data and simply process it. And that's how your parallel execution or parallel processing happens in Glue Job by using Spark task. So pretty straightforward fundamental. You have multiple workers. Within workers, multiple Spark tasks take care of processing a portion of data using certain vCPU and memory allocated to you. How many Spark tasks run within a worker is roughly determined by how many vCPUs that worker has. Like for instance, in this case G.2x, a worker has 8 vCPUs, so you can say, yeah, 6 to 8 Spark tasks might be running in this worker type. Again, there is no public documentation, but I have gone through certain information. I'm trying to simply use that information to give this indication, but there is no public documentation which confirms how many Spark tasks per worker is started. But the idea I have got is that it's roughly equivalent to number of vCPUs you have per worker. Okay, so now that I have understand these workers and how Spark tasks run within the workers and how these Spark tasks are responsible for processing a part of your file by having certain CPU, vCPU and memory allocated to it. Let's try to understand the problem. The problem is this parallelism sometimes becomes a very high degree of parallelism. So what happens that and when you have high degree of parallelism, it gives error. So what happens, Glue automatically enables grouping of the files into this Spark task if number of input file exceed 50,000. So if they have more than 50,000 files to be processed, then by automatically Glue does grouping of your files to for parallel processing. And here comes the problem. If your number of files are a lot, of course they have to be more than 50,000, if they are a lot, then due to high degree of parallelism, so looks like there's a typo here, not parallelism but parallelism, um, your Spark driver may run out of memory when trying to read large number of files, and you get an error something like Java heap space out of memory error. So if you see this out of memory error Java heap space, then you should know that you are seeing a situation of high degree of parallelism, and you need to do optimization of grouping of your files to get rid of this error in your glue job. So how do I do that? By controlling parallelism. Very simple. And how do I control parallelism? So when I'm reading data from S3 in my glue job, when I'm reading and reading into a data frame, I need to do something in my glue job when reading data from S3 bucket to control how many files will be allocated to or what size of data will be allocated to my Spark task. Okay. So how do I do that? It's pretty straightforward. You know this. We all know this. Glue context create dynamic frame from options, and in this from options, actually, you can provide two parameters. So like in this case, what this piece of code does is saying that, hey, I'm reading from S3. This is my file path. Go recursive and look for all the files beneath the tree, beneath the root path, and my format is JSON. My file format is JSON. Then you provide two more parameters. One is you're saying group file. You're looking into in partitions, and then your group size is, and this is actually this is in KB, so it is roughly it's 1 MB in fact. So what you're saying by providing group files and group size, you're saying that my Spark task, by virtue of this code, will be allocated 1 MB of a data file, not more than that. So that way you can achieve parallelism. Again, I put 1 MB here, but it could be 2 MB, 4 MB, 10 MB, up to you. But these are two parameters, group files and group size, which you can use to control parallelism in your parallel execution, control parallelism in your parallel execution when trying to read and process your data file. So it not only helps in reducing and avoiding the out of memory error, but it also helps in performance. And in fact, I'm going to share two quotes provided by AWS where it is claimed that it does improve the performance. So for instance, they took a scenario where they're trying to process some 320K small JSON files spread across S3 partitions, 160 at S3 partitions. And what they realize is that when they use this in partition grouping option, like the two configuration I showed you earlier, in partition and group size, then it was processing 7 times faster. So controlling this grouping mechanism not only helps you avoid the out of memory error due to high degree of parallelism, but it can also help you improve the performance of the glue job. And performance improve by doing the grouping, because otherwise your glue jobs or in fact Apache Spark spends a lot of time building the in-memory indexes and scheduling large number of small files with small tasks, or in other words, short-running PySpark tasks. So keep this in mind, guys, that whenever you are processing large amount of files and you come across this memory optimization, out of memory error, you can avoid that by using this grouping of the file mechanism. And when you do so, it can also help you improve the performance. So time for a demo. What we're doing is pretty straightforward and simple demo. What I'm going to do that I have an S3 bucket in which I have created some partition data. And that partition data is, we have got like 124,000 records, which is spread across 17K files, and total size of the data is 32 MB. This I'm trying to read in Glue Job using grouping mechanism. Then I will perform some simple transformation and write it back to the S3 file again. So this is a demo which I'm going to build to show how this group mechanism works. So let's get started. Here is, I'm in AWS console. So first let me show you the data. So this is how the data look like. So if I can go little further here. Yeah, oops. Can I show it here? Yeah. So this is how my data look like. So you can see here, I have tried to fetch some kind of some IoT data from Kaggle, and then it is showing my date, device, device failed or not, and some 9 different type of matrices. So this data I have tried to upload to S3 bucket using partition. So if I go to my S3 bucket, in my Dojo My Data bucket, I have a sensor data as folder. In that, I have simply uploaded my data in partition by device ID in this case, by the way. So I've simply, so this is my source location from where I want my Glue job to read my partition data. And as mentioned you, this more roughly 17K files are there, and then total 124K plus records. Now I want to write my output to this output folder. Right now this folder is empty. And for that I will write a Glue job. So let me start Glue Studio. But before I start Glue Studio and create a Glue job, let me show you the code I want to run. So this is how my code look like. So if I go on the top first I import some libraries for Spark context and Glue context. Then I'm starting my Glue. Starting my Glue context, creating a Spark session. Yeah, and then the first statement comes, which is using the from options. I'm trying to read from the S3 file. Here I'm reading from the S3 file, from the S3 bucket. Format is Parquet, so my data is in Parquet format. So my location is so Dojo My Data sensor data. Then I've also enable recurse to true, so that it takes all the tree within this folder. Then I'm saying my group files is in partition, and I kept my group size to 1 MB. So I just told you group size is presented in KB, so it is 1024 into 1024. So, and these many. So what I'm saying is that each of my tasks will process, each of my Spark tasks will process 1 MB of data at any point of time. So that's how I'm reading my sensor data. Then I'm simply applying some select field partition transformation to my sensor data. I'm saying I'm only interested in my record date and failure, and then I'm simply writing that to my output location. So you can see here I'm writing my sensor data frame, dynamic frame to S3 in Glue Parquet format. This is my output location, and I'm saying my compression is snappy type. So that's what I have done. I'm going to provide this whole code snippet in the description box, as a link in the description box. In the description, I'm also going to provide you location to the data. So if you want, you can upload this data to your S3 bucket in a partition way, and then can run this code to test it at your own end, or you can test using your own data as well. So Now time to create a glue job. So I go to my AWS Glue Studio. I'm going to create a job. I want to create a blank canvas. Let's close this. Create. And oops, in fact I don't want that way. Sorry, my mistake. Since I have a code, I can simply go and say create. I want to create a Spark script editor. Create a new script using boilerplate code. So let's create it. So I'm not using any drag and drop approach in this case. Since I have a code, I'm simply going to copy paste the code. So I simply come over here, copy the whole code, and as I mentioned, this code I'm going to provide you, and I simply paste the code. As I mentioned earlier, straightforward. First we import all libraries, then we simply start the Spark context and session, and then we first read data, and most important, we read data using grouping of the files, so that each of my Spark task will simply process 1 MB of the file, not more than that. So I'm controlling the parallelism in parallel execution in my Spark task, and then it simply applies a select field transformation, then writes output data here. So what I'm going to do is that I go to my job details, and then I give this job a nice name. I will call it this is my dojo job. Then in IAM role, I'm going to provide glue job role. I'm using Spark, Glue 3, Python. Let's use G.1x. Number of workers 10 is default. That's fine. Let's keep it like that. And I don't want number of retries to be 3. I want it to be 0 because I want to know the failure as soon as possible. But in production environment, generally you want to have number of retries to certain number because you want to give your job a fair chance to complete in case it got stuck due to some reason. So you save this job data over here, job code over here, and then I'm simply going to run the code. So when I run the code, you can see here it is running. Now it will take certain time to read data from my S3 bucket in a controlled partition way, a parallel way, and then it's going to apply the transformation and then write data back to the output location which I have configured in my glue job. So let's wait till this job finishes, and then we'll see if it has written the output or not. So let's wait. Okay, so you can see my job has succeeded. Now if I go to my dojo my data output location and I refresh it, it should show me the output files created. You can see that it created some 556 output files by applying the select field filter transformation on my source data, and it has written that as a Parquet file. So you just saw an example how you can create a glue job where you can control parallelism in your Spark task by deciding what is the data size you want to send to your task for the processing, and that way you can avoid out of memory error, and it also helps improve the performance. So that was all for today, guys. Hope you liked the video, and if you like, please click on the like button. Please subscribe to my channel. I always look forward to your feedback, your comments, which help me improve my content, and if I have done any mistake, I try to fix it based on your feedback. I also like to discuss any of the design or architecture things you want to talk about AWS services, or about one of the videos which I have already presented to you. So I look forward to your feedback. I promise to come back again in a week's time. In the meantime, please stay safe and have a nice day. Bye-bye.